So here at the Living Computer Museum, one of the most important aspects is that the computers are real and they're actually running. And if you look around, you'll notice there's empty chairs in front of every computer. And when there's an empty chair, all you have to do is sit down in front of it and start typing. They often have instructions as to how to do it. You probably should know your basic programming language because a lot of these run BASIC. So here we are. I'm sitting at a Heathkit H19 and I'm going to print 2+2. Of course, I did a syntax error. And now it worked. So for me, that's one of the coolest things about this museum is you can sit down at a teletype or a terminal or a key punch or a mini computer and just sit and touch it, and it's not all hidden behind glass. So come with us as we take a look at some of the interesting artifacts and meet some of the people here at the Living Computer Museum.
A lot of museums, computer museums, that their artifact is like a special holy thing. You put it away carefully and then you don't use it for anything in particular. But this is a really crossover between a parts lab and a museum. So the items that are in the collection that are findable are usable. So we will use them to replace things in the computers.
This particular module, there's 56 of these in various machines all over. All our DEC machines. It was a standard module the DEC produced. The problem is replacing these capacitors every 10 to 13 years because they wear out. And so what we decided to do was come up with a contemporary design that basically fit in the same form and function, and then they basically made it into this 3D printed module. So there's no solder connections anywhere. It's highly reliable. This is of a size that basically if it degrades over time, we don't care so much. And then this is a mill grade power supply module, and then this is the rectifier. And we also found that the connector that DEC had used was underrated, and so we replaced it with a modern type that actually has a higher rating. So basically built a bunch of these, and they're all in the machines now.
And how do you even figure out that that's the problem that you need to solve?
Well, when I first got here 13 years ago, we had to rework a bunch of these. So we bought capacitors at the time, and it came up like 10 years later. They started failing again, and so we said, well, we counted the number of modules we have. It was like, oh my God, it's going to cost us an arm and a leg. Not only that, these guys, the ultra large ones, aren't available anymore, or they'll build them spec to spec, but so you're going to spend a huge amount of money. Now, this entire module costs us $350, and that's once. And these things are mil spec; they're guaranteed for 40 years. So we don't have to look at this thing.
So some of the problems just come to you over time, basically, right? You just, with enough experience, you just go, okay,
exactly.
This month, that's the problem we're going to solve.
So the other thing is that by using this new module, this is a linear supply, it has about a 15% efficiency. This has a 90% efficiency, and so we automatically saved 10 tons of air conditioning that normally would have gone in out as heat. So the machines run cooler. They fail less often, and we're not repairing them as often. So,
and when you turn them on and off, they don't tend to burn themselves up and things like that.
Exactly. So
yeah.
That we are working to restore these computers is one of the things that makes it special. And the other thing is that we make them available to people on the exhibit hall and also online on the internet, people can log in, get accounts, and try out different operating systems that are really running on the real computers. So in this case, I'm working on a EP8E mini computer, which is interfaced. The input-output device is this ASR33 teletype, a very classic piece of equipment used all around. What I'm going to do is start BASIC and ask the machine to do a very simple mathematical operation. So first, I type in, I'm going to run R BASIC. That tells the computer that we're going to run it. It wants to know if this is a new or an old program. This is a new program. The file name, I'll call it LCM. It's ready for me to program it. Here's the first line. Asking it to print 2 plus 2. The second line, I have to tell it that's the end of the program. Now I'm going to ask it to run the program. It tells me today it's running this program. There's the answer. The answer is 4, so it knows how to print 2 plus 2. That's great. Then it says it's ready for another program or to run it again. You have different age groups. Older people come, and they often have a feeling of nostalgia. They will have used this stuff, and they will express delight. Oh, look, I had one of those. It was so exciting. Ooh, wow, I remember that. And they look back at the days when computing was really quite difficult. You'd have to use cassette tapes to load your programs, or interact with them with a teletype. Some of it is to demonstrate how far we have come in a very short period of time from these giant supercomputers to our telephones, which have more computing power than is in the entire museum.